We are Team Odyssey. We have namely 4 subsystems: mechanical, science, CS and electrical. We are participating in International Rover competition this year. For the further details, my teammates would speak on this.
Hello, we are from the mechanical subsystem. We design and build the rover. The rover is built with carbon fiber rods and 3D printed tough PLA and TPU materials for the joints and the wheels. We also used metal parts sandwiched between 2 3D printed parts to provide additional strength while also keeping the system light in weight. For the suspension, we are going to use the trailing arm suspension along with a differential. Coming to the arm has 6 degrees of freedom with 2 linear actuators and 4 rotary actuators for precise control and easy manipulation. The end effector is a gripper which can perform variety of tasks. The end effector can be swapped with a drill which collects the soil samples, which is based on the principle of Archimedes screw. It collects into a soil collection chamber.
Hello guys, I am from science team. We are working on presence of life in soil. When our rover drill the soil, taking one soil sample, put in 3 different tubes. One is presence of NPK, means nitrogen, potassium, phosphorus. Another one is sulfur. Another one is carbon. We create a model which is used to measure the NPK, means nitrogen, phosphorus and potassium. Another one is sulfur. We use sulfur strips and calculate the presence of sulfur. And using limestone, we can easily calculate the presence of life in soil.
Hi, we are from the CSC subsystem. Our main role is to make the rover move autonomously. Our rover uses Jetson Nano. It's a single board computer. It performs specific tasks like image processing and navigation. ROS Melodic acts as an interface between electronic components and the computer system. We have opted for Intel RealSense stereo camera as it performs well in depth perception. Object detection has been carried out using YOLO V8. The rover navigates through the A-star algorithm. Gazebo is a 3D robotics software. We simulate the rover in the gazebo first before deploying it in real world. Finally, we are using the depth data from the camera and object detection to calculate the distance between the objects and to help the rover navigate autonomously.
Hi, the electrical and electronic subsystem integrated components for power management, sensor integration and communication aspects. For the power management system, implementing battery management for efficient communication throughout the rover. For the communication aspect, we are using 2 antennas. One antenna which goes on the rover and the other antenna which will be at the base station, working in a 5.8 GHz range. For the arm, we are using 3 different motors. One for the base, which is a stepper motor. Then the linear actuators, which are Force Flex 1500. And the end effectors, which are generic DC motors, which work in a 12-volt range.